Morning, people! So, Macaulay brackets. Kinda like the kid from Home Alone, huh? Well, let's jump right in and see how they work. So yeah, what are Macaulay brackets? They were discovered by famed Macaulay Culkin as the thieves were skulking about. Nope, that's not what it is. We're talking about another type of Macaulay. First off, Macaulay is the name of the fine fellow who invented these things. The brackets themselves just look like this. They're basically just greater than and less than signs. And like with any other brackets, Macaulay brackets usually have something in them. Usually it's something like this. And what are these brackets doing here? It's pretty simple actually. The special thing about Macaulay brackets is that if they contain a negative value, it becomes 0. And for positive values, they behave like your run-of-the-mill parentheses. Here's a bunch of examples. Whenever the stuff inside the brackets has a negative value, the whole thing becomes 0, and all other values just stay how they are. Well, hey, that sounds easy now, doesn't it? There are two important ways people like to use these brackets. If you raise the expression in the Macaulay brackets to the power of 0, then they basically work like an on-off switch. In this case, if x is less than 6, the result is 0 as usual. But if x happens to be greater than 6, the expression in the brackets is positive, and the 0 exponent means that whatever value you get, it just becomes 1. And this is always the case, no matter what the value of x is, even if it's 11 billion. Any positive number to the power of 0 is always 1. But I know you guys already know that, because you're just on top of things. But if the exponent is not 0, but some other number n, let's say 2, then things go more like this. If x is less than 6, the expression still becomes 0. But if x is greater than 6, instead of 1, we just get whatever the value of the expression in the brackets is. Yeah, that's cool and all, but what the hell is the point of all this? Well, let's take a look at a little example. Macaulay brackets are really useful for describing the point at which a force or a distributed load begins to act. Have a look at this beam here. Here we have a uniformly distributed load with 0 acting on a beam. And we want to use Macaulay brackets to help us figure out how intensely and where it's acting. First, we're going to figure out the starting point of the shear force. Here it's just 2/3 the length of the beam L. Now we need to indicate that starting at 2/3 L, the value of the uniformly distributed load jumps to W0 and stays there. And before you get to 2/3 L, the value of the uniformly distributed load is just 0. Sweet. So all we have to do is turn on the uniformly distributed load starting at 2/3 L. This form of Macaulay brackets are perfect for this. For S, we just plug in the point where the uniformly distributed load starts, so 2/3 L. Now when we multiply this expression by W0, we're done. But we're going to go ahead and check one more time if this is right. Let's go ahead and plug in a value for x that's less than the value of the starting point. Let's say 1/2 L. Then the value we get in the brackets is minus 1/5 L, which gives us 0. Awesome! Now let's try it with a value that's greater than the starting point, say plain L. 1/3 L is a positive value, but because of the 0 exponent, we're actually going to get 1 for the whole expression. So now we can see that we have the right answer. So much for a uniformly distributed load, but you should definitely check out the video on triangular loads after this one. It shows you how to use Macaulay brackets with other exponents. Then you can do our practice exercises to make sure it all sticks. But first, let's go over what you need to remember from today's video. Macaulay brackets are great for describing the starting points of forces and distributed loads. If the expression inside the brackets is negative, the result is 0, and if it's positive, then they work just like normal parentheses. And finally, there's a difference between the 0 power and the nth power. Have at it, guys! Take care!